Okay, let's talk about graphs of cubic polynomials first, which means it's the highest degree is 3. So it start with x cubed. And then quartic polynomials, so we're going to also take a look at graphs of those, polynomials with 4th degree. And then we're going to talk about general polynomial in a standard form. So standard form is basically ordering it from the highest degree and then go to the lower degrees. So you just write in order. So that's the standard form. But you're not going to see only standard form when you deal with some problems. So there are so many different forms. So let's categorize our cubic polynomials into 4 different categories. Okay, so what we're going to do today is we're going to have some discussion to find each type and then take a look at the graphs of it. All right, we're going to do this together, but I might need a slight help from you. So what you're going to do is create a form, the first type, with 3 distinctive real zeros. So basically, you are going to have a polynomial with 3 zeros because you have something that looks like 3 linears, x minus the first 0, x minus second 0, x minus the third 0 gamma, and then a is not 0. You're going to have something like that. So basically, alpha, beta, gamma, they are your 3 zeros. So, Julie, can you give me just pick any kind of number between -5 to 5?
0.
First, you have 0. Okay, x minus 0. What's your second 0?
-2.
-2. So x -2 or x plus 2? I'm not clear.
X -2.
X -2. Your second 0 is 2. What is your third 0? Pick any number between
X plus 3.
3. So your third 0 is 3. All right, so what do you want for A? Leave it as 1 or you want some big number?
5.
5? Okay. All right. Okay, so I am going to guess. Okay, so if I plug 0 here, what happens with the entire px? Duh, that's the definition of factor theorem, right? So what Julie gave me is 3 zeros, which means instead of x, you plug 0 and 2 and 3. I have all zeros. This is my first clue. Okay, so let's kind of guess what's going to happen. So I have, when x is 0, I have 0. When x is 2, I have 0. When x is 3, I have 0. So you have those coordinates completed. Okay, but I still don't know what's going on between them. So significant numbers. Can I plug -1 to see if it's going up or down? So what's going on when you have -1 instead of x? -1, -0 is just -1. -1, -2 is -3. -1 minus 3 is -4. So what do you have? Negative times negative times negative is negative. And then 5 times 12, it's -60. Woo! So you go all the way down. I understand. The very, 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 very down below. Okay. What happens when you have P1? 5 times 1 times -1 times -2. So you end up having 2 times 5 is 10. When you have 2, you're going to have 10. So sorry, when you have 1, you're going to have 10. So you have all the way up there. And then I'm pretty sure you have to come down to hit this 2 and 0. So I am pretty sure you have to go down and then up again like that. Right, so it's not very accurate, but I kind of guess that this is the general pattern of your polynomials. So you can put it in your calculator and check if your guess is right or not. Okay, so I'm going to ask a question now. What happens instead of 5, right? Instead of 5, if you have -5, what might happen? Julie, what do you think? So here, you have 5 and then it looks like that. But if you change 5 to -5, what do you think it might happen? You can use your GDC now if you have it next to you. You're welcome to use it and then answer.
It goes opposite.
Opposite. In terms of what opposite?
Reflects against the x-axis.
Ooh. So basically, you have this increasing pattern for positive number for A. When you have A is negative 0, negative numbers, then you mean it will go like, so reflected. So it's going to be something like that.
Yeah.
Yeah. Yes. Because when you have, please recall when you have x is, y equals x, which is linear graph, and then y equals negative x. So we have positive slope and negative slope, right? So we have this case, and then we have negative slope case. So it's kind of similar. So the first coefficient gives you the general direction. Is it increasing or decreasing? Very good. How many x-intercepts in the first type? How many x-intercepts? How many zeros? Hanan. So here's 0 and 0, 2 and 0, and 3 and 0. How many meets do you have?
3.
3. Very good. So 3. How many x-intercept, right? As you can see, this is alpha, this is beta, this is gamma. So you have 3. How many turning points? Do you know what turning point is, guys? Can you say again? I can't hear you.
2.
I can't hear you. What did you say? Okay, never mind. So turning points in life, when you say I have a turn, that was my turning point. You know, when you reminisce your life and okay, that completely changed my life. That was the turning point of my life. That's how they say it, right? So turning point is something like that. So let's just think about the roller coaster. I really like the roller coaster in polynomial. So you know, when you're in the roller coaster in your theme park, and then you have to hit the maximum point to go down. So like you're building the height. And then you hit the top, and then from that moment you're going to and then like speed goes up like and then go up again. You know what I'm saying? Have you been on the roller coasters before?
Yes. Yes.
Yeah. So when you're in the roller coaster, you must go up to be able to go down. You must hit the lowest point to go up, right? So basically, it changes your direction. I mean slope. I mean if it's like increasing or decreasing slope. So what I'm asking you here is that how many different directions? As you can see, we started with positive slope, and then we hit the first 0 of the turning point, and then go down again and hit the second turning point and go up again, right? So how many turning points do you see?
2.
Very good, 2. Okay. Why am I asking you these questions? It's because it's a pre-calculus class. And then in calculus, you're going to need all the functions to be differentiated. Basically, I'm just giving you all the ingredients. So you have to understand this polynomial with turning points and also slopes and the intercepts. Those are just important for calculus. That's why. Okay. So I'm not going to speak too much about calculus. So only thing you have to know is turning points. All right. So 2 real zeros and 1 repeated. Now I want Boram. Can you give me your favorite number between -5 and 5? Because we have to complete alpha and beta. You only have 2 choices. Sorry, because it's two zeros now. Give me any number. You construct it.
4 and -3.
4 and
-3.
so it's a +3 here.
Yeah.
Okay. And then what's your A? Can we just leave it as 1?
Yeah.
Okay, leave it as 1. What happens when you have 4? Duh. She just said 0, so duh, it's gonna be 0. No need to discuss. Okay, let's talk about some important points to be able to graph. You can already graph by yourself. Do you have this GDC next to you right now?
Wait a minute.
You can play with it if you have it. I just want to discuss how to sketch the graph without a calculator, because with calculator it's so much easier. Okay, so when you have 4, you have 0. So 3, 2, 1. And -1, -2, and -3, you have 0. That's very good. Okay, now, when you plug 0, what happens? 0 minus 4 is 4, -4. And then when you square the negative numbers, it's a positive, right? And then when you square them, 16, and then 3, so that gives you 48. So when you have 0 for x, you're going to hit 48. Woo, that is a very big number. Okay, so how about when I plug some number less than -3? So we know that between -3 and 4, you have to go up and down again, right? But what if before -3? So -4, what happens? -4 minus 4 is -8, but that's going to be 64, positive number. And then -4 plus 3 is -1, so you have -64. So it seems like you have to go way down and then go up here, right?
Mhm.
So what happens? What happens if when it's greater than 4? What do you think?
It increases.
It goes up to positive again because 5 plus 3 is 8, so your answer is 8. 8 is positive number. So when you have 5, you're gonna hit 8 right here. So it seems like, I don't know the maximum point, but like it will kind of like, I don't know, look like kind of like that.
Mhm.
Or I might be wrong. It might hit somewhere else earlier and then go up again like that. I don't know. But what I know for sure is that it has a shape looking like that. Oh, wait a second. I am completely wrong. I'm confused between the first type. Okay, so what's going on here? We're in the type 2. So let me correct my answer. I made a big mistake here. So, sorry. This is the case when you have 1 repeated 0, right? So it seems like 4 is your repeated 0. So you're going to have only hit here and then go up again. Right? So it has exactly 2 zeros right here. So your minimum point in this positive number line is going to be 4 and 0. All right, so that's what it's going to look like. So here again. So in conclusion, what's going to happen is that you have first alpha here and then beta here. So what happens if you have negative number for a? Same, positive a and negative a, right? It's just opposite, negative slope. How many x-intercepts in this type 2 bottom?
2.
Very good, because alpha is repeated, right? How many turning points do you see?
2.
Very good. Okay. So that was number 2 type.